Okay, so what we're going to do is go around the room and have you ask a question, and let's let the rest of the class answer it, okay? And just a reminder, on next Tuesday is the midterm exam. It'll be somewhere between 150 and 200 questions. Is that okay?
Oh, Lord.
Well, maybe not quite that many. But I'll take 125. Can I have another bid here? Okay, and you can have your design notebook, your class text, your computer hooked to the internet if you want. We haven't got a schedule yet for a lab midterm, but I would expect it would probably be a week from tomorrow, because I think the following Monday I have to hand the grades in. So I'll outline what I want you to do. Basically, it'll be demonstrating that you can run your basic stamp, maybe even show that you can actually run your RC card a little bit, so you need to interface that. Does anybody in here need some extra help in the lab on the basic kit, or working any of the DC problems or anything like that? Anybody need help? Everybody feels pretty confident about it, okay? Because I'm available. I will schedule extra class times with you, at 6 o'clock in the morning if you want it, or at 6 o'clock at night, or at 12 o'clock at night, or on the weekends. I'm available to help you, because this is the point in the course where if you're not caught up, it's going to get more difficult from here on. So I'm going to kind of go down the roll here and have you ask questions, and we'll expect answers from the rest of the group here. So let's start with Kennedy. Do you want to look at random on your sheet and ask a question? And pick somebody to answer it.
I have to pick a person?
Yeah. Just turn around at random. Somebody that's been pestering you for a long time. Just, you can get back at them. Who would that be? Okay. What's the question? Real loud.
Are school work ethics any different from job ethics?
They shouldn't be.
They shouldn't be?
They shouldn't be, but they are something, but they shouldn't be.
Right. Did you pick her?
Yes.
Okay, all right. Let's see. Maria, how about you ask a question?
Kennedy. Okay. Is this class only for those interested in working in space?
No, it can be used for lots of different things.
Name another occupation that this class might be useful for.
Systems engineering.
Okay, good. All right. Cody?
Odd cadence. Because they already each had another question. Alright, at what altitude is there virtually no ballistic drag?
Come on, Cody.
That was easy. Wait.
Is it 62 miles? I don't know. I have no idea.
Maybe 1,000 kilometers.
1,000 kilometers. Well, I went to today.
Okay, now why? Explain the difference. What are you thinking of when you say...
I was thinking of that's like where we determine where space is. I don't know. I had no idea.
Right, yeah. Well, that's right for what you were thinking.
Yeah.
But as we'll see later on, as you go up in altitude, it's less and less. But, 1,000 kilometers or probably more, it's almost insignificant compared to other things that are up there. You might get more, and we're always looking for things that perturb the orbit that you've got into. You spend all this money, all this energy getting into orbit around the Earth, and then there's all these things that disturb the orbit. So one of the things is drag, right? How much is the drag at the space station altitude? Is it negligible or some?
Significant to the point that they have to be pushing it back up in the...
Right. So in that area and below, there is significant drag. Okay, let's see. Since you weren't, do you got some questions?
I just wanted to see if my sister knew this one.
No.
Oh, mean.
If you don't, then I'm just very disappointed.
What kind of stars do twinkle in the night sky?
Big gap. I'm thinking off the top of my head.
She's close.
Yeah.
Alright, try to put more and more together. So.
Where are the gases located?
Why do you have to do this? I might not be alive if you do this.
Yeah, correct. Very good. Okay, Ember.
Alright, when, hold on.
Take it easy when you're in. Please.
Why is communication through satellites more effective than ground communication?
Because there's less interference in space.
Is it?
Somebody want to add to that?
Bigger distance can take the message longer.
Yeah, you can use different wavelengths.
Right.
There's long distances, you got more of the railheads around.
Yeah, you can see more things from space, right? If you broadcast from space from a geostationary satellite that's way out there, how much of the Earth can you see at one time? Not quite. You can see about a third of it. But you can't see up at the North Pole and the South Pole because you'd have to be how far out to get to the North Pole? Right. Very good. Okay. Next question here. Do you have your questions? No questions. Cadence.
How much velocity is needed to keep a satellite in orbit?
Oh,
17,000 miles per hour.
God, they need to
sorry, I didn't know that off the top of my head.
Well, gee, gosh, Cody, why didn't you know that? That's crazy.
Yeah.
I mean, I wasn't hating on you. It's the one I randomly select a question and then ask somebody. It's like, I want that one.
Always take the easy.
Nick, do you have a list of questions?
No, I forgot.
You didn't do that. Okay.
What is the minimum height that you can have and achieve orbit for a short amount of time?
Who? Ask somebody.
120 miles, I think. I know you get your wings at 50 miles. No, wait, I'm thinking kilometers. 120 kilometers?
130 kilometers.
Okay. That's considered where you're in space. But can we really keep satellites up there? Yeah, maybe they can make an orbit or so. Right.
Too much drag.
Right. Okay, Frank, what's your question?
What are the four fundamental forces?
Strong nuclear force, weak nuclear force, electromagnetic, and gravity.
Is that right?
Gravity.
Okay, good. Okay, let's see. Will, can you remember any of them?
Oh yeah, I've got. But I don't know who I want to ask.
Actually, let's see if you remember what I talked to you about last night. How can you correct processor upsets from particles as they come and hit processors in space?
You can use some wire to create current to block it.
One of the ways you can do it. The other one has to do with using multiple processors and daisy chain them together so that
The voting system.
yeah.
Yeah.
you'll be able to create
Okay, there's two kinds of things that happen with particles to electronics. What are they? Single event upsets and latch-ups. What's the difference?
A single event upset when a particle comes into the transistor and flips it from 0 to 1.
Right.
That can be corrected. The latch up is typically when something comes in and fries a piece of circuitry from it.
Or puts it in a state where it generally draws a lot of current. And so what you do in your power control system, you have something that monitors the amount of current, and if it exceeds a certain amount, then what do you do to correct a latch up?
We just talked to this in this class. But we were using UARTs and SPI interfaces and why you can correct it.
You turn the power off. Generally turn the power off when you have a latch up. Single event upset is like in RAM, and how do you know you've got a single event upset if it's part of your program? It what?
Error, but sometimes it's almost impossible to detect unless you have some type of redundancy in place.
A lot of time they have a EDAC. It's error detection and correction on memory. So you write it out into memory, and what you do is a lot of times you'll write twice the number of bits that you have for data, and you have this hardware that can correct it. So when you write it out into memory, it sets those bits, right? And then when you read it back in to use it in the processor, it checks, and if it's wrong, it uses the extra bits to fix it. Okay, or you can use multiple processors and vote. And if you don't fix it in a instruction, if you change one bit in an instruction in a processor, it changes it to a whole different command. Let's say you said, high 5, you're just turning port 5 on. It might be a go-to if the bit gets changed. And we have a thing on the processors on the satellites that are called a Watchdog timer. And what does the Watchdog timer do? What do you have a Watchdog for? Right. What you have is you have a counter, okay? And that's the Watchdog timer. If the counter goes you set it when you start your program, and it counts down. And if it gets all the way to 0 and is not ever reset, then it resets the processor, turns it off, starts it again. So what you do in your program as you're executing through your program is you want to get back and reset the Watchdog timer if everything is right. Generally what happens if you get one instruction wrong, it won't continue to execute in the sequence you want it to, and means you can't get back and reset the Watchdog timer. So.
Isn't there also, and this was more transmitting than it was the events inside of a processor, but there's a type of mathematics that we were talking about when you're sending data to prevent corruption when information is transmitted from point A to point B. You can run through with an algorithm and see if any particular bits are misplaced and this misplacement has to be flipped back and forth.
Yeah, it's called a Viterbi code. And we'll talk about that when we get into communication. So, Murphy, ask a question. Real loud.
How much of the solar system's mass is the sun accounted for?
Like 99.9% of the mass of the solar system.
99.86.
Oh, gosh. Okay, David?
Who is the father of modern rocketry?
Werner von Braun.
Von Braun.
Von Braun. All right. Yeah.
Who else was involved who were some of the early guys that did rocket experiments in the U.S.? Goddard, right, okay.
Over came here later.
Yeah. Eric.
What's Sputnik? Right.
Is there a little buddy system going on here?
The first unmanned satellite man-made that made it into orbit lasted 3 months. I think it communicated for 2 weeks and just made beep, beep, beep. So, and radio operators all around the world to see that it was actually
What was this strictly for technical and scientific purposes?
no, it was to prove that they could put a warhead up in space.
Right. It was political, right? Really a political statement. Brian?
What was the most famous bomb rocket and what we used?
Who do you want to answer that?
Jeremy, the Redstone was used as an ICBM and a platform to get to space.
Okay. All right. Let's start over. Oh, Amy. I'm Amber.
I have a question about Sputnik. Would it actually have been possible for them at that time to calculate when specifically Sputnik was going to come down and where it was going to come down? Would they be able to calculate that so that if it was a bomb, they would have been able to drop it specifically where they wanted to?
You know, I'm not sure whether they had the data that they needed on atmospheric density in order to know that. I don't think they did, but I don't know. My guess would be not, because I don't, you know, it's so even now that with all of the information they have on, you know, orbits and drag and all of that, it's very hard to even predict when something is going to come down through the atmosphere and where it's going to hit. There's a really big, when they know something is coming in, they give an area of probability of where it's going to hit. And the area of probability is really a big area. You know, it's like, you know, big as half the United States sort of thing. I think it's going to land in there. So when they have something like warheads, they actually have some guidance systems on them to put them more where they want them. But if it's just plain deorbiting like the Sputnik, I don't think they did. Okay, any other questions before we go on? Are you ready for another one? Yes, please. When you ask your questions, mark them on your paper because I want you to hand the paper in with the questions you've asked.
How about if other people ask you questions?
Pardon?
What if other people ask you questions? Like if you have questions, somebody else asks.
Mark it on the sheet too.
Maria, who will give you reference for a job after graduation?
That's right.
Maybe.
Maybe.
Okay. Don't worry about it. Just ask another one and then mark it.
Okay. Kennedy, what is the rover looking for on Mars?
Mm-hmm. That's true. Why do we want to find water on Mars, or why do we want to find water on the moon?
Aside from hope for life, it's also a good resource if you wanted to base there.
You need water for what? But beyond human, you need it for fuel. Okay. Has any of you heard about the project called Flashlight? What is Flashlight? Anybody that'll answer it? Anybody? How many have heard of the project that Moorhead has a proposal with JPL for NASA to do? Okay, tell us what the rest of them tell us what it is.
Okay, so it's a proposal for CubeSat, and well, it's a CubeSat proposal with JPL to NASA, and they're going to use giant football field-sized solar panels to reflect sunlight into like a crater on the moon, on like it's like on the South Pole.
I think so, yeah.
And the solar panels are so large that it's going to make an elliptical orbit around the moon. That's why we can get to the South Pole. And we're just using the light to look into the crater.
And if they shine light down there, how can they tell what's there? Do they just take a picture of it?
I don't know, I didn't.
Okay, what's that?
Yes, probably one reflects back.
And what do you look at what reflects back with? What kind of an instrument?
I'm not sure.
What?
A satellite?
Well, you got the satellite, but it's got an instrument on it. And what is it? What is it that does the reflection? Is it a solar panel? But is it the solar panels that reflect the light? They have a solar sail. They're using the solar sail to use the force of the sun, the pressure of the sun on the sail, to adjust the orbit. They will have it do an elliptical orbit with the perigee, which is the lowest part, close to the South Pole if that's where they're going to look. Once they get there, they orient the solar sail so it reflects light into the crater. When they see the light in the crater and the reflection that's back, they look at it with a spectrometer, which can tell them what is down there.
Why are we looking in a crater?
Because they think they have no conclusive proof at this point how much water is on the moon at the places they've looked at. They've run satellites into it, they've run orbits around it and everything else, and there's no conclusive proof about how much water is there. But they think because of these craters, they think that there is a lot of water there because the sun never shines in it to evaporate it. So that's a pretty wild experiment. That'd be pretty neat. So you will have the opportunity here, and they've selected 3 out of something like 20 proposals or more, and this proposal was number 2. So that's pretty cool.
I'm pretty sure Jeff has to go to JPL.
Right, yeah. Boy, I don't know about sending Jeff to JPL. That's dangerous. Good old Jeff.
Bad because it's 2 days before his conference.
Right. Okay. Is it your turn?
Yeah.
Okay, be sure and mark your questions.
I'm going to ask Kennedy. What was the original name of the first successful German rocket? No, just like
Saturn.
no. It's just like an abbreviation, or like not really an abbreviation, but it's literally one letter and one number.
V2.
V2 was what it was changed to. The A4.
A4, okay. But I think it's more important to remember the V2 because that's the one that they actually got into production. And what was their, I think we answered this last Tuesday about what was the major purpose of the V2? Was it to blow up buildings or kill people or scare people? It was the fear factor they were looking for. And you can imagine that. Have you ever seen any films when about those times when those things were coming over? You could hear that motor, coming over. And what was bad is when it quit, because they knew when the motor quit, it was coming down. So that must have been really scary, so. Okay, do you have any questions you could ask?
Ever once free-falling useful to create new metal alloys? You can create more of a uniform mixture because the heavier metals don't stick to the bottom.
Cool. You can see that evil glint in her eye, Did everybody hear the question? What's the distance of 1 light year?
93 million miles. That's
Give a simpler answer.
9.8 times 10 to the 8 meters per second, so whatever that is.
1 light year is the amount of time it takes light to travel from in 1 year, right?
300 million meters.
Do you want a specific answer or just a general answer?
Well, the answer that I found in the book was 9.46 times 10 to the 12 kilometers. That's the distance traveled in 1 year.
Okay. Good, thank you. Cadence?
Okay. Will this one? Or how big is MSU space tracking antenna?
Okay. See. Do you want to give your sheet to Nick and let him pick a question off of it?
Frank. How many astronauts have there been?
A little over 100, 200, 400. 556.
Around.
Around 500, huh? Okay. All right. Jeremy. Okay.
Because it's not like, there's like,
It's not infinite.
smallest amount of space, small amount. If the universe is continuous or discontinuous, it was a pretty vague question. But
Give him a vague answer.
I guess you could ask if it's infinitely divisible.
yeah.
There's a set unit for the smallest, that's small.
Okay. Here's a good question. And I don't know what is you're an astronomer. You like astronomy, right? What is the boundary with which electromagnetic waves on the Earth have reached at this point? What is that boundary called? Do you remember? Have you heard of it? Okay. When was the first time on Earth we started producing electromagnetic waves for communication?
Yeah, it was the first one was
Who is the guy that did it?
Hitler's for the Olympic Games, something like that. wasn't it?
Tesla or Marconi?
Oh, okay, we're going to do it longer.
I think it was probably Marconi claims it, but I think Tesla did it. But that's interesting. That electromagnetic wave travels at a certain velocity, okay? Since the first production of electromagnetic waves, which would be probably something for radio, if you could go out there and stick up an antenna, all of the things that have been broadcast on Earth would come by you and you could listen to them. So from the 30s or whenever Tesla did it, you know, that's a fascinating thing to me that you could stick up. Now, it's got to be an awfully good antenna and an awfully good receiver because, you know, that spreads out. As it spreads out, you know, in all 4 pi steradian directions, it gets weaker and weaker and weaker, like when you drop a rock in water in a lake. You know how the circles spread out? That's the way it spreads out, but it spreads out in 4 pi steradians around the Earth. So if you could stick that antenna up, you could hear all of the broadcasts that have happened on Earth since then, if you're in the right direction, of course. So that's kind of cool. So one of the things that we're going to do in the latter half of this is we're going to talk about orbits, but we're going to be able to go into the Star Theater, and they've got some really, really good videos and stuff on all of the stars and the satellites and all that, and I think they'll show that to us. Okay, who is next? Okay. Now let's see. You two did not get a set of questions, right? Okay, I want you to go through and get a set of questions, and I want you to email those to me.
How many questions do you want?
10 per section. Okay?
Will, are matter and energy interchangeable? And give me an equation to prove it.
Yeah, because it writes E equals mc squared to conserve matter and energy.
Okay.
What is the greatest limiting factor when considering radio communications in space? I actually don't know this one, so I'm out.
You always wanted to. Here, guys are asking questions they always wanted to find out, but they don't know the answer. That's okay. Frank will know it.
I guess maybe the fields around whatever body you're orbiting, or maybe the particles and radiation just from those bodies as well, like stray gamma particles and whatnot.
Isn't it overcoming the signal-to-noise ratio that's present in space, which means you need something like a 10 dB gain once you compensate for distance or something like that?
Right. Well, distance is the factor, and what happens is remember, you're sending out this electromagnetic wave, okay, in space, and there are other things out there that are generating noise. For example, if you point a receiver towards the sun or towards the moon, you'll hear noise. So it's a matter of how much signal you've got compared to the amount of noise that's there. You've got to have, on certain kinds of modulation, and we'll talk about modulation, certain types of modulation, you have to have the signal so much farther above the noise. And what happens if it gets down in the noise? Have you ever heard on your radio when you're driving along and you're hearing a radio station, and the farther you get from the station, the weaker the signal gets, till pretty soon all you're hearing is noise? So you're listening to the change in signal to noise ratio. Your radio even has a circuit in it that monitors the amount of signal that you're getting, and it boosts the gain in it. It's just like you turning up the sound, but it gets to a point where it can't exceed the noise that's there. And you've heard noise on your radio, right? Do you hear more noise with AM or FM? AM. Why?
Longer wavelengths?
No, it turns out that in FM, it has a way of, you can prove it, but there's a way that the signal actually suppresses the noise a certain amount. So the FM stations, just because when they say FM, they're talking about frequency modulation. And here you got a frequency, and they vary the frequency to put the information on the wave. But what would they do with AM modulation? They vary the amplitude on it. So we'll study some of those things in this class. Okay, who's next? Will, okay.
Does that mean all AM stations are on the same frequency?
No, they're on different frequencies. They allocate different frequencies for them. But they're just more noisy. What happens if you drive under a 60-cycle power line? Right. What happens if that trucker's behind you and he gets his CB out that's got 1,000 watts in it? You ever hear them on the freeway? They blow right through your receiver, even though they're not the same frequency. I'm sorry, Murphy. Go ahead. Very loud.
How does the sun create energy?
Nuclear fusion. Okay.
Murphy. Who is the main Russian scientist involved in the design of Sputnik? No.
Hold on, let me look.
It's a rough one. I don't know.
There's somewhere. I don't know. Say it. I really don't.
Well, how would you find that out during the test? Google it, right? It's legal in this class. Google it. Okay.
Sergei Korolev.
All right. Good. Eric?
How many people does the B-2 rocket kill?
It's not 5,000.
I'll ask you anyway.
He was prepared for you. Okay. Mark the questions you ask.
But didn't it kill 20,000? Like,
In production. But that wasn't,
technically it's 25.
that wasn't my question.
Okay.
What is your question, Judy? How old is Jeff?
Loud. Nice and loud. For what? Hey, hang on here. What's that? What government agency was founded for aerospace? Anybody? Who? NASA. Everybody hear that? What was the agency that was formed particularly for space? Right? Was it, you're calling it aerospace, but space. Okay, what was the organization that did that before? NACA? Okay. All right, let's see. Back here again. Give them a hard one.
Oh, a hard one?
A hard one.
Okay. All right, Cody. Are you ready for this?
All right.
Hold on, I'm going to pick myself a really, really hard one.
That one.
Okay. Oh, okay. What percentage of mass does the sun account for in our solar system?
We've already done that one today.
Right?
But it's
I was testing to make sure that you knew. We had already done it.
Okay.
Okay. Of the four major components that make up the universe physically, dark matter, dark energy, okay, all right, yeah. Which of these components make up most of the universe?
Dark energy.
Right.
Okay. Maria?
Ask her again.
Where does the Germans get most of the labor to build the B-2?
That was easy one.
Concentration camp.
Give him a hard one.
Okay. Cody?
Maria. How is matter organized?
Wait.
How
Expand
is-
on that question a little
How
bit.
is matter organized?
As in,
You can't really expand much on that.
Like there's like different tiers of matter. Remember we got like there's like 12 different tiers.
Starting with the
Hierarchy.
smallest unit of mass.
What?
Then a hierarchy.
Okay.
Smallest to biggest.
No,
Like the little, the O word,
that's cubed.
the cord.
That's right. Okay, so what's the next one after that?
I don't know, an atom, then,
No.
like electrons,
Well, yeah.
and then protons and neutrons.
No, electrons and protons and neutrons are all the same tier.
Okay, and then
Atoms.
atoms, then molecules, elements. Oh my God, why are you having me?
I don't want you to listen much. Just what? How is it organized? Like it's a hierarchy.
All right. Okay. Who you going to ask it to?
What has the biggest effect on space environment in our solar system?
Oh, very good.
She saw the answer.
Okay.
What did Aristotle predict about falling objects?
Did you hear the question?
up must come down. The larger the object, the faster it falls.
Why?
Because it makes bigger. They didn't have 32 feet per second catch.
Okay. Okay, what is meant when something comes back in space and reaches a terminal velocity? Let's say a skydiver. What is meant by when a skydiver reaches terminal velocity? What determines that? Yeah, what kind of drag he creates coming through the atmosphere, right? Okay, I guess it's Frank.
I gotta mark out these questions real quick. What protects the Earth from outside radiation and string particles? Anyone? Jeremy.
Dang, I knew this one.
Okay. Cadence?
Oh, yeah. Dang. Jeremy's just too smart. He's too smart.
But I'll tell you what, he needs to improve his handwriting though, doesn't he? What did you say, Cadence?
No, I was gonna say-
The what?
I was going to say the atmosphere.
There's another thing that protects us from the radiation particles.
You said the magnetosphere, the magnetic field.
The magnetosphere is part of that, but it's really, I guess it's the magnetic field. The magnetosphere is just part of it. What's the bow shock, or what's the bow magnetosphere bow? Have you ever heard of the bow? When the radiation particles come from the sun and they start coming into the Earth's magnetic field, do you remember seeing the pictures where it kind of goes out around it and it kind of flattens it out, and then it goes around it, and then there's a tail out at the end? That's the magnetosphere bow, the front of it. Just like a bow on a boat. Looks like it's going through the water. Okay.
What is the universally accepted distance for space?
The AU, the astronomical unit.
I mean, like for at the atmosphere.
There's no formal definition of how large the atmosphere is.
Okay. Nick?
What are the 4 categories of space radiation?
4 categories of space radiation? I'm stumped, I don't know.
Plasma, solar particles, trapped particles, and galactic.
Oh, okay, okay. Yeah.
Okay. All right. Cadence?
Well, it's the same. Who do I want to ask? Might as well ask Cody. What happened to the first Vanguard launch?
Failed. Just failed the launch and then exploded.
Good job.
Yeah, I'm gonna ask Cody one too. Seems like a cool thing to do.
Alright. Everyone just hop on the bandwagon.
Obviously, what's the smallest unit of time?
Quantum. Is negative 1/3.
Okay, Will?
This one is for anybody. Name the 3 particular types of particles you check for.
Electrons, protons, heavy ions. Protons are more.
Heavy ions are the odd man.
Okay. All right. Murphy. Nice and loud.
How many satellites are in orbit?
A lot.
How many? 120? 120,000 or 120?
You mean like working or?
Yeah, working or just floating around?
Okay, I'll ask a different question.
So what would you do if you got that question on the test? Google it.
What is the velocity of solar wind?
What is the velocity of solar wind? Right? Did everybody hear that question?
About 300 to 900 kilometers per second.
How long does it take a solar flare to come from the sun to the earth?
They travel at the speed of, well, according to this, it's 300 to 900 kilometers a second, and we're pretty far away from the sun. It takes 8 minutes at the speed of light to reach us, so a fair bit of time. I think about 2 weeks is what I heard.
I think it's something like 70 hours. Google it.
Google it.
Google it. Okay.
Thanks for
David.
Frank. What is the smallest component of matter?
Good. Eric.
Is space dangerous?
To what? To whom? To humans?
How is it strange and weird?
Yeah, the human, okay.
To humans?
The humans. Is
Why?
space dangerous to humans?
Why is it dangerous to humans?
Because there's got the radiation, you got the charged particles, you got the
Right,
space
no air.
junk, you got the you got the Van Allen belts, you got, lack of atmosphere, no air, not enough, not much air.
Has anybody seen the advertisements for the show called Gravity? Yeah, looks bad, huh? Oh my gosh. When's it due out? Tomorrow? Oh, we ought to cancel class and go tomorrow, hadn't we?
I'm serious, let's do it.
He accepted that real quick, huh? Brian? Okay, can anybody answer that? Who discovered the Van Allen belts? Oh my gosh, what a smart bunch. Okay, how did he discover it?
It was discovered when we launched, what was the satellite? One of the first ones, wasn't it?
Was it Vanguard? Oh, okay. Where is Van Allen from? Huh? No. From one of the northern universities. What is it? Wisconsin or?
Iowa.
Iowa. Yeah. He's from Iowa. Iowa State or Iowa University?
University of Iowa.
Okay. All right. Let's see. Who? Okay. You asked the question, right, Brian? Okay. Kennedy, we're back to you.
Okay. Okay, Maria, are you ready?
Yeah.
What war encouraged the rapid development of space industry?
World War II? Or was it?
Well, it started.
It started
That's right.
with World War II,
That's
but
right.
it went through.
That's right. Correct.
Okay.
Cody, what are the 7 unique things in the universe?
Unique things in the universe? What do you mean?
Yeah, I don't know the answer to that one either. It's, it was like there was like a, what said 7 unique things in the universe?
I have no idea. I'm Googling that one.
Okay. What we'll do in the future when you write questions, we'll have you write the answers down with them. So. Okay. Cody.
Yes.
Okay, I'll ask Kennedy this. Okay, so there was a problem. The first problem that the German rocket team faced was the melting of the thruster casings with like fuel in it and they would explode. Okay, how did they solve this problem? We watched it in the video.
Good question.
Okay, wait, what was melting it?
Okay, so like
The
all the flames would shoot out, from, like, but the flames would end up melting what was holding the fuel.
the cone, the rocket
Yeah.
nozzle.
Yeah, and then all the fuel will be exposed and they explode.
Yeah, I do remember this part of the movie. I don't really know either. Did they just move it somewhere else and move it up? It's not, I don't know.
They cycle fuel.
Oh, that's right.
That's right. They put. That's when you look at the when you look at the nozzle on rockets, you'll see it looks like a tubing that's welded to the outside of the nozzle, and they run the fuel through it, cools the nozzle. Not only that, it heats up the fuel. So the hotter the fuel, the more combustion they get. They did one other thing that was pretty cool too. What did they do?
Coated the inside.
They had a spray that coated the inside, right? To keep it from melting. Okay. Yeah, they still got pretty good data out of it, but it was a pretty interesting mission. Okay, let's see. Frank, it's your turn.
I had a good question in mind. How do we know that the Big Bang was 13.7 billion years ago? Besides math, like what physical proof do we have? Stop answering questions.
Okay, but what's happening? What do they think is happening to the universe? It's expanding. So is it expanding at the same rate all the time? The rate's changing, right? Okay, Jeremy?
What did the Russians launch after Sputnik?
Sputnik 2.
Yes.
Okay. Nick?
What color light does oxygen emit? Blue. Green.
Okay.
Okay. For anybody, what's the biggest damaging impact exposure to space radiation has on human beings?
Mutation. And cancer.
It was more vague than that. It was
Yeah.
just DNA breakage.
Right, yeah.
But those are answers.
Okay.
I would think death is the most damaging.
You die.
How was dark matter discovered? Anybody?
What?
How is dark matter discovered?
For anybody?
Not so.
Technically, it was math because when you did the math for the spiraling galaxies or whatever, like the outside, like would slow down, but actually it speeds up the outside spiral. Yeah, the arms, yeah.
Okay. Well, it's your turn.
Don't you just...
Frank, what is the biological mass of consciousness?
3.7 grams.
What? This is a random question that I Googled when I Googled top 25 unanswered science questions.
Not given the
No, Frank, what is the largest object ever launched into space?
like
The largest
at
single
once
piece
or
of-
in parts?
I'm curious, what was the largest single piece, like let's say the single biggest satellite ever launched into space?
How's it, the satellite?
Yes, what was the single largest satellite launched into space? I guess Hubble.
Hubble's pretty big.
Actually, but Hubble they keep adding attachments to.
Yeah.
Is the thing. Do you know what was Hubble the biggest when it first went up?
Well, the shuttle.
I probably think
The shuttle itself is like a satellite. I would say that's the biggest. The biggest satellite that I know of is one called Millstar, and that's about the size of a school bus that the military has that Lockheed makes, and when it gets up it unfolds, and it's a big communication satellite, probably one of the more expensive ones. So it's got to be pretty close.
Is that also the heaviest object ever launched into space?
I don't know.
it must be probably part of the ISS.
Yeah, the ISS. You're right. ISS is the biggest contiguous thing in space, right? Is it bigger than the Mir? Space station? Yeah, okay. All right, I would suggest that you have a study group, that you as a group get together and ask these questions. So turn your questions in to me or send them to me with the ones marked,